Hey folks, Mr. Dell here. We are looking at finding area of what they call as composite figures. When you're taking shapes that we know and put them together, we call those composite figures. Okay, so these are that's a composite of looks like a square and a triangle, right? This one is a composite of a triangle and a rhombus. All right, so I'm taking this problem from CPM's course 2, and this is section 5.2.6, number 584. So I'll read it and we'll go through it. So it says manual use pattern blocks to build the shapes below. The block marked A is a square. Oh, look at that. They actually tell me. The block marked A, so that tells me it is a square. The block marked B is a trapezoid. So that right there is a trapezoid. And C over here is a rhombus. And D is a triangle. Find the area of each of Manuel's shapes. So in order to find the area of a composite figure, you find the area of each of the known figures and then add them, right? So for this one, my area, I'm going to take my total area is going to be, area is going to be equal to the square plus the trapezoid, right? So I need to figure out the area of the square, the area of the trapezoid, then add them together. So let's do each one separately. So the area of the square. How do you find area of a square? Area of a square is always length times width, right? You multiply the length times the width, or side squared, because really it's the same side. So for this problem, our sides are 2.5. So 2.5 times 2.5. Okay. So when you multiply 2.5 times 2.5, it's 6.25. So that is 6.25 is the area of that square, right? Now, to find the area of the trapezoid, the formula, that one's a little tougher. The formula for the area of the trapezoid is taking it's 1/2 times the height. The height is in this case, 2 times, and then what they do is they add the bases, base 1 plus base 2. So that might be something you write down, because that one's a little harder to memorize, but knowing the area of the trapezoid, if you got a trapezoid, all you have to do is find the height and then you add the bases. What are the bases? The bases are the parallel lines are the bases. Those two lines there are the bases. So that's 5, and we know that one it's not labeled, but we know it's 2.5 because it's a square, right? That's on top of it. And the height, in this case, is the one that's 90 degrees to the base. So it's 2. So I'm going to say 1/2 times 2 times, and then I've got to take 5 plus 2.5. Okay. So to get that order of operations, I want to add those up first. So that's 7.5. So now I got to say, and then I can actually look at this and go, well, what's 1/2 of 2? 1/2 of 2 is 1, right? Half of 2 is 1. So what's 1 times 7.5? Well, 1 times 7.5 is 7.5, right? So there's my area. So my area of my trapezoid is 7.5. I'm going to put it right here. And the area of the square is 6.25. So the total area is going to be adding those up. Okay, so I need to add those two up. And looks like I'm out of room down here, so I'm going to move my answer up here. Those two added up is 13.75. So how to add those? Remember, you want to add a 0, line up the decimal places, and then you can go from there. So the area for this figure, this first one, is 13.75, and it's centimeters squared because it's in centimeters. So there's the area of the first composite. So again, once again, review. What did I do? Found the area of the square, found the area of the trapezoid, took those two numbers, added them up to get the total area. Okay. So second one, this case, my area is going to be, again, I've got to add 2 up, right? So my total area is going to be the area of the triangle, and I'm going to add that to the area of the parallelogram, or in this case, rhombus. So I'll write rhombus. They're both the same thing. A rhombus is a parallelogram. So how to find the area of a triangle? The area of a triangle is always 1/2 times your base times your height. So you multiply 1/2 times base times height. So here's my triangle. So my height in this case is, it tells me right there, 2.2. So it's 1/2 times my base. Though, what is my base? Well, it tells me that this side here is 2.5, but it gave me a little hint up top. It told me that the triangle, oh, it didn't tell me. Oh, I know how to find this piece right here, actually. This piece right here is the same length as that because this is a rhombus. All right, so rhombi have all equal sides. It's basically a square that's been like just tilted square. So we know that that right there is also 2.5. So that's my base. So remember, your height and your base have to match at 90 degrees in order for them to be the height and the base. So it's going to be 2.5, 1/2 times 2.5 times 2.2. That math might be a little bit uglier to deal with. Um, multiply half of, I could look at it this way. Remember, you can multiply out of order. So I can take, first of all, half times 2.2. So I would actually have 2.5 times 1.1 because half of 2.2 is 1.1, right? So, and then you multiply, when you multiply the two numbers, ignore the decimal, and then um, move your decimal place. So all in all, what you get here is you get 2.75. So that's the area of the triangle, 2.75 after all said and done. So the rhombus, how to find the area of a rhombus is base times height. So it's base times the height. It's like a rectangle, except it's been tilted. So you just need to find the area of find the base, find the height, and then go from there. So it looks like my base is 2.5. That's what it says here. That's the base. And the height, it tells me, is 2. So it's 2 times 2.5, which is equal to 5. So now my total area is going to be 2.75 plus 5. So I'm going to put my answer up top again. So the area of this shape is going to be 7.75. Oh, and centimeters squared, because that's how we write area in square units. Okay, there we go.